Well, hello, friends. Today we're going to work on Doom again, and I would like to make it go faster because it does feel a bit sluggish still, and I'll show you what I mean. And you can especially see it in the CPU graph up here that we are getting very, very high CPU usage, especially while I'm using OBS to record a video at the same time. Basically, like maxing out on CPU almost the whole time. And you can see that the game is not entirely fluid. So let's try to improve this situation. So to prepare for this, I have made a port of Doom, like a fork rather of the port that we were using. So now if you look at the script here, you can see that we are getting our own port, and we'll build it from scratch. So the only difference between the port fork and what we had before is that now if you go into the fork, you can see that I have added the initial patch that I already had, but there are no changes other than that. So let's go in the Serenity Doom folder here, and this is the code, and I guess let's try to make this a little bit easier for ourselves by importing it into Qt Creator, so I don't have to use Vim all day. Source, Serenity, blah, blah, blah. Where are the ports? And we'll just import this. We'll call it Serenity Doom. And okay, blah, blah, blah. No, don't add those. Okay. And what was that thing called? Doom generic Serenity. Oh, and all of these includes. Maybe we should help it out a little bit. We can do. Let's see. How do we do this? Doom generic. No. Wait, we are in Doom generic, and then we are in Serenity Doom, and then we are in Doom, and then we are in ports, and then we are in the Serenity root. No? Am I not getting that right? No? Oh, that was one step too far? Oh shit, okay. Hardest programming problem in the world here. Ah, look at that. Okay, and then we just need to also have this in our path. And no? Why are we not picking up ref footer? There we go. Okay. Just so we add all the fancy completion and stuff. Anyways. Actually, maybe I should also tweak this. Okay. So this is like the port file where we do all the action. So I guess the first thing we're going to do is just figure out what is Doom doing. And I don't have a fancy profiler or anything, so we're going to do something extremely simple. We are just going to open up the system monitor, and we already crashed, but let's just ignore that. And we're going to grab Doom here. Come on, buddy. Why don't you cooperate? Alright, come on, Doom. I just want to look at Doom. Okay, so the selection up here is a little broken, but we can definitely see Doom stacks down here. So this is my extremely cheap profiler that I'm using right now. So we're just looking at the stacks. We see a lot of I finish update. I'm profiling in my head, counting the stacks. I finish update, definitely suspicious, and these are deep stacks. It's probably doing the game loop. Let's see. Draw frame. Sleep, that's fine. Finish update again. Finish update. Render player view. Render player view. Finish update. Finish update. Finish update. Finish update. Okay, so finish update. That's definitely the one that we want to be looking at. So let's see what that's about. Oh, wait, hold on. Am I in the right? Okay, I've been here. Let's have a look at this. Okay, so I finish update. Blah, 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 blah. And then CMap to FB seems to be the thing that we were calling on the stack. And then we have a mem copy here that copies to the screen buffer. So CMap to FB. Okay, so it's taking an input. That's an 8-bit input. And I guess looking them up in a color map, which we have 256 colors. And each one is one of these. So, okay, so I know what we're gonna do. We are going to, instead of doing this in Doom, we are just going to use the, there's a graphics, so graphics bitmap has a feature called indexed 8. It's a separate format where you can create a graphics bitmap in Serenity that has 1 byte per pixel, and then you have a palette where you can assign each color here. So I think we're just going to use that because then we have optimized routines for taking a small bitmap that's 8 bits per pixel and scaling it up. There's a fast path for that, so we can take advantage of that, because instead of doing this doesn't look optimized at all here. So let's do that. So how do we do that? CMap to FB, CMap to FB. So this code path, I guess, is what we want, where it just does a mem copy instead. That's only in 2 places, CMap 256, so I guess we'll just enable that. And I guess we can also, we don't have to preserve the other stuff. So let's see. I think like that is fine. So now we're just mem copying the thing. But I bet you that we are gonna have some trouble somewhere. So there's a bits per pixel constant that's set somewhere. Looks like here, it's 32. We're just gonna set that to 8. And then in the Doom Serenity thing, where we create the bitmap, here, we're going to create it with the indexed 8 format. And yeah, the data size is not going to be ×4 anymore. So I wonder if we have that in more places that we got to clean up. Doom. This one looks related. Yeah, screen buffer no longer needs to be ×4. Other than that, I don't see anything Doom related. Okay, fine. So let's try this. Let's say make clean 95 and cp Doom root bin. No? let's see if this works. Assert that format is not index state. Seems like we have some code that does not support that. Graphics bitmap CPP. Right here. So we don't allow you to construct a graphics bitmap. Oh, I guess it's when you do create wrapper, we assume that you only ever want to create a wrapper bitmap around a RGBA 32-bit storage, but you might want to do it around some other type as well. So we probably just going to want to do this. If format is index state, then we just create a palette. Boom. Okay, and I see that we have a different one down here, but we can just leave that alone until we run into it organically. Okay, let's just try that. So I guess we have to rebuild everything now because we're changing libdraw. This doesn't look right. Okay, so what did we do wrong? Oh, we're forgetting to set the palette colors, obviously. How the hell did we do that? That's iVideo. Color, there was a thing at start here somewhere. I guess we don't need that. Color. Here they are. Okay. So when is that updated? Colors. We can set them here. I set palette. Okay. Then how about after we set the palette, we just do, or actually, do we need these for anything? Colors. Are we using this? No, we can just get rid of this. Zoop. And we don't need this either, I think. So I think what we really need here is just this stuff, but we want to instead set it on the graphics bitmap. So maybe we'll just call out to the Doom generic port function that we'll add. So set palette colors. And see, colors, we'll have to define this outside. So we'll just put this in iVideo.h. I guess. Do we have any struct definitions here? Oh, whatever. It's fine. Okay. And then what was it? Set palette? Doom generic.h. Oh, can we include iVideo here? Just so we get the definition of that thing, and color. Color. Does this work? RGB for blah 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 blah. I was using that somewhere. I don't. Oh, do I need this thing? Get palette index. Okay. Maybe I was, oh fuck, I was getting a little too removal happy there. Alright, I got carried away. I put the things back, I'm sorry. But this one we definitely stopped using, so you can go away. Oops. And you can go away as well. 565 palette. Apparently that one we are still using. Alright. That's fine. Then set palette, we're going to change. This is where we update that one though, so maybe this just doesn't matter. I don't know. I'm getting confused, so let's just stick to what we're trying to do instead. Set palette colors, okay. Struct color is redefined, okay. Video .h struct color, because now it's in the header, so type name color doom generic.h const struct color. Okay, now we just need to implement set palette. And then I guess we'll just do like, we'll just iterate through all of the possible colors. Because I don't imagine that the game would try to set the palette very often, so I don't think we need to super optimize this or anything. Set palette color I, colors I, oh wait, hold on. Let's, red, green, and blue. Okay. And oh, and let's see if we can get the makefile to build using Ccache here. I'll just do pre-cxx. Wait, you don't like that? Maybe. Because I'm kind of, yeah, we can get Ccache to do this. Then it's a huge improvement because then it's much easier to rebuild after this one initial build. Okay. And that's a whole build now. Cool. Okay, so let's try this. Now that we are setting the palette as well. Boom. All right. Does this do much for CPU usage? Oh, well, goddamn, look at that. We're not nearly at the top anymore. So we're definitely seeing an improvement in CPU usage here. That's awesome. Game still plays okay. Still a little stuttery, but definitely better than before. Okay, so let's see what we have changed so far. In Serenity itself, this is a straightforward change to commit. Graphics bitmap. Allow constructing a wrapper bitmap around indexed 8-bit pixels. Hold on. This will be very useful for optimizing games. And like Doom. Like Doom. Alright. And then we have all these changes here, so let's do the makefile first. pull in Ccache via pre-cxx if possible. And what else? Status. Oh, these are annoying. I'm just going to add these to the git ignore. Zit. Creator gunk to git ignore. Okay, and then what did we do here? So now we're making the game render into a 8-bit bitmap instead of a 32-bit bitmap, basically. And we're adding a set palette thingy here that takes the palette from the game. CMap 256. What was that? Oh, it's not needed anymore. Yes, we generate the 8-bit bitmap, copy the palette over, and then when we want to copy the bitmap of the game to the port, then we just memcopy the bitmap with no color expansion. What was that? iSet palette. Well, commented out code is not doing us any good, so let's just tidy this up a tiny bit. Okay. I can't press the auto format button because it will just go completely crazy on this file. I don't want to do that. So yeah, I think that's good. And then yeah, okay, so use in graphics bitmap, an 8-bit palette, graphics bitmap for the game, screen buffer. This allows us to use the optimized upscaling code ready instead of the non-optimized code in Doom. Yeah, that's good. I mean, it also, or no, we don't have to talk about that, but I was just thinking we could talk about how it's smaller in memory, but you know, it's kind of obvious from changing the bit size. Finish update, blah, 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 blah. So now we just iterate over all of the scan lines, starting at the bottom, copying everything over. And then we copy the video buffer to the screen buffer. But why is that necessary though? Can't we just copy directly to screen buffer? Like, what if we just do that? And just don't do anything here? Then what would video buffer FB ever contain? It would just be malloc and freed. Okay, so, oops. Then maybe we can just get rid of those entirely. Wouldn't that be nice? And let's try that. Oops. Because that's, I mean, that's like, how many bytes? 64,000 bytes that we don't have to memcopy for every frame that we render. So it's definitely desirable to avoid that. And the game seems to work just fine without it, so there's no need to have that extra buffer. Cool. Okay, so this, I mean, it didn't feel any less stuttery really, but we can still do that as a patch. So remove unnecessary extra screen buffer copy. We can just draw the game directly into the TG screen and save ourselves a 64,000 byte copy per rendered frame. Cool. So why is it still feeling kind of sluggish though? Like, let's see if we can run the system monitor thing on it again and see what it's doing now. Okay, we got Doom. And what are you doing? Just draw a frame. Sleep, a lot of sleep. I feel like mostly it's sleeping. What if I just start spinning? Still, we're mostly catching in sleep. Though we're in the some render function. Okay, so now we're mostly catching him when he's asleep. That's a good thing. Oh, here we are, render player view. Back to sleep again. So the fact that we're catching him asleep, that's a good thing. It means that we're on the right track. But it's stuttery. Oh, there we are. So let's look at the way that we do the updates. So, I mean, this is a hack job. So when the game tells us draw frame, which comes from iVideo finish update, right? So at the bottom here, when we finished generating a frame, we call it draw frame, and then here we pump the event loop, which is kind of weird actually, because like it's not telling us pump your event loop, it's telling us draw the frame, and then we draw the frame, or we initiate the frame, actual frame drawing here on a timer every 33 milliseconds. So, I mean, ideally, we should actually be doing this, and then this should be in like a separate helper called like pump event loop. Then we shouldn't have this timer at all. But then the question is, where do we pump the event loop? Guess where's the Doom main function? D main. Okay. Doom main. This is. Oh. I guess this is the main event loop. Or the main loop of the program, at least, because this is Doom loop. And frame synchronous file operations, try to run text, blah, blah, blah. And then display at the end, and then start over. So what if we just pump event loop here? What would happen? It might not be enough to only do it this one time. I don't know how much work happens in between these things, but session false. Yeah, it's this client buffer overflow. So what this means is that the Windows server tried to send a message to the Doom program, but his Windows Server socket buffer was full, which means that he's not processing his incoming events fast enough. So maybe we can just work around this, like by doing it, I don't know, maybe that way? I don't know, we'll just see. like obviously we should do as little of this as possible, because every time that we do pump event loop, we will go to the event loop and we'll do a select on all the sockets and stuff. So it's good if we can do less of it. But oh, okay, so maybe we didn't need more than that. Oh, wow, that is so much better. I hope it comes through in the video, but like it is just so much more fluid. Very cool. Still the occasional stutter, but it's definitely better. CPU usage, it's gone up a little bit though, I feel like. I don't know what that's about. Can't pick up the phone right now. So what am I even looking for? Oh, it died. Shit. Oh, he died too. Everybody's dying. I just want to look at the stacks, please. Okay, so what is he doing now? Sleep? A lot of sleep. I feel like we're mostly catching him in sleep. Oh. It's a lot of syscalls though, like thousands per second. Oh, and then we crashed for some reason. I don't know what happened. What did happen? Assertion failed. False. Well, wait, why is it doing so many syscalls? We have strace, so we can figure out what they are. I guess maybe we can just do strace doom, actually. Oh, shit. Even made the terminal die. Why did the terminal die? Alright, who knows? Let's say that we strace it from a separate terminal instead. 27. Okay, well I saw a lot of getted and then we died. This Windows Server socket overflows are kind of irritating because they don't happen nearly this much if I'm not recording at the same time. But it's kind of illustrating a problem that we're having, that obviously we shouldn't crash this easily. So let's see if we can get some more data. Yeah, it's just getted. Definitely the majority of it is getted, which is get thread ID, which we use in the event loop. Here, because we take a lock, and then the locker checks the thread ID. I mean the lock, when you call lock, zoot, then we will ask what's the current thread ID. But now that we have thread local storage, we could actually just cache the thread ID, I guess, if you've ever received it or retrieved it. So What if we just did like thread, thread IP cached tid int, and then actually like that. Say if t cached tid is -1. I think we can just do that because like there's no need to do the system call every time. We can just call it the first time, because this means that it's unique for every thread, this variable. Puts it into thread local storage automatically. It's a very nice feature. So then it will just remember that did. Let's see if that works. That would be really nice actually, because then we get rid of all of that syscalls that using locks would incur. Okay, Doom. It's running. And get out Doom. Oh wait. Look at that. Not a single get tid. It's a lot of get time of day instead, but it's a different issue. Oh, it's so smooth compared to before. Damn. Ah, so good. Okay. So definitely let's do the get tid change. Let's see. Get tid, get tid cache, thread ID in thread local storage. Tid, very cheap compared to cost of having to do a full syscall every time. Yeah, that's actually, I really like that change. One thing is a little bit weird though. I feel like there's something missing. Like when I start the game here, boop, the screen is supposed to like somehow, you know? Why is it not doing that? So I think maybe we're screwing that up somehow. I don't even know what I'm looking for. Freaking 8. The tab size here is different than what I'm used to, and that's why the indentation looks all wrong. Wipe update. I think that wipe is what they call this. Screen wipe. They do a melt. Yeah. So these are wipes. So how does it work when they do a wipe? What does it mean to do a wipe even? Wipe. Do melt. Finish update, draw frame. we're gonna have to pump the event loop in order to get these paint commands out to the Windows server. Because right now we are just like drawing the screen in the Doom process over and over, but we're not telling the Windows server because we're not pulling the event loops. We're not receiving any go please repaint yourself messages from the Windows server. So we're just like melting the screen and not showing it. So screen wipe. Mjar. This is the menu. Page flip or blip buffer finish update. Okay. So yeah, right. So if we're in a loop like that, if we're in a loop and we're calling finish update, then we have to pump the event loop manually. Because this is the regular display, which is called by the main loop. So the main loop here takes care of pumping the event loop, but in the other instance of, what was it, finish update, it was here. It's only called in two places, so this is the other place. So here we have to advance the event loop manually. So do dg pump event loop here, and I think that'll sort it out. No, I didn't get that thing. Okay, why not? Display pump event loop. Okay, I'm not really sure what's wrong with this. There we go. Okay, I just was doing it in the wrong place. Oop. Let's try it again. Look at that pipe. Pretty cool. So we have to pump the event loop before we call finish update, not after. So maybe we can avoid doing it after. No. Okay. Let's do both. That's very hackish. It's very hackish, but who cares? I guess we're buffering up quite a lot of messages from the Windows server in that time, so we gotta take care of them. And then we do. It's really good. Okay. So CPU usage, I want to say it's a little bit up from before we did the event loop integration stuff, but at the same time, it's very, very fluid and very nice now. So I think that's good. Yeah, so let's commit what we have. Integrate better with the serenities. Look, the event loop. The event loop down. Drag the serenity event loop. And let Doom's finish update drive repaints. The one weird case is screen wipes, and we have to manually pump the event loop a little extra to make sure the screen wipe effect shows up on the screen. This patch makes the game a lot, way more fluid. Cool. Okay, so I think we're gonna push that to our cool port. Oh shit. Damn it. Okay, I have to fix that up later. Or maybe actually I can just because the port script, they just check it out. We can just do this. Serenity Doom. There we go. Okay, so now we've pushed all these changes. Let's try to see that it still builds as a port. We're gonna just run the port script. And let's run the new and improved port. So very, very good. All right. That's awesome. Okay, so I think that's as good as we're gonna get today. So if you made it this far with me, then I thank you for watching, for hanging out while I optimize Doom for Serenity. And I hope you saw something interesting here. And hope you have a great day. And I'll see you next time. Bye.